we are Jiun Park and Jaeran Choi. Our title of project is ARGoose Interactive Choir Synthesizer. First, I want to share our main idea. We wanted to map some sound effects, what we learned in the class, to Goose interaction in the augmented reality environment. And this is our key concept part for mapping sound and interaction. And there are two interactive functions. First, vertical interaction is mapped to a pitch shifter of the sound. So like as a left graph, if goose height go higher, then the pitch goes higher as well. And if goose goes down, the pitch also goes low. And second, one of the horizontal interaction is matched with the flanger effect of the sound. So if goose become fat, then the flanger ratio and depth goes higher. But if goose becomes slim, the flanger effect goes lower. Now this is our demo video part. There are two key functions about sounds in our AR application: interaction and spatialization. Now I'm gonna talk about more detailed method. We implemented based on Unity AR Core by Google, and for making the real-time mixing in AR, we used FMOD Studio, which is the sound engine library that enables real-time 3D interaction. We used FMOD instance to edit the soundtrack individually by 4 vocals in real time, while the playback to control sound effect, panning, and volume. And we did pre-processing for audio preset, and their original MIDI sound from Logic X. And we made the virtual instruments using 3 Goose sound sources, which are high and low and wings. And we this recording sound by Logic Sampler. And finally, we could make vocal sounds from the keys like this.
As we aim to create a controller of the pitch shift and the flanger effect in real time, we designed each sound effect curve in FMOD Studio as shown on the right. The vertical shape of the goose graphic is synchronized with the pitch shift value, so as the goose gets taller, the pitch of its sound also increases in real time, and vice versa. Let's see an example. Okay. For the flanger effect, which is mapped to a horizontal interaction, we both designed the curves of the rate and depth of the flanger effect to change the timbre of the sound. As the goose gets fatter, each flanger rate and depth value goes higher to make a very thick and fat sound. On the contrary, with small values of flanger rate and depth, sounds are going to be very, very sharp and slim. system, the sound volume is attenuated and panned in proportion to the distance between the user and each 3D Goose object. It spatializes the signal passing through it by panning it according to the angle from the user direction of facing the 3D object, and it attenuates the signal according to the distance between the object and the user. It also upmixes or downmixes its input signal to the master bus. We modify 3 variables for our system, which are mean distance, max distance, and the envelopment size. This is possible by adopting 3D object spatializer effect provided by ARGoose Studio to each audio instance to create an immersive and realistic sound. We apply 3D object spatializer to each voices and manipulate the parameters, making the audible position of each Goose object in our system better match what the user sees on the screen. After pre-processing the preset audio files and setting all the audio effects for each voice in ARGoose Studio, we integrate the UI component, ARCore, and ARGoose Studio in Unity all together using the C# script. ARCore is a software development kit developed by Google that allows for augmented reality application development in Unity. We take full advantage of this feature, the main AR function for placing 3D objects in AR environment, followed by horizontal plane detection. We map the slider UI value to audio effect parameter set in ARGoose Studio in real time. So whenever the value of the slider UI changes from 0 to 1, the pitch shifter or flanger effect parameter values detached from each Goose object are updated every frame to synchronize with each other. This is end of our project, and thank you very much.